Hey guys, this is Forces in One Dimension and Two Dimension Practice Problems, and number one, we're looking at finding our own mass in kilograms with the following information. We've got a kilogram weighing about 2.2 pounds on Earth. What is your mass in kilograms, and what is your weight in newtons? Well, there's two parts to this question. Part number one, we are looking at how to find our mass in kilograms. So the way we do that is we say that 1 kilogram, I need a pencil. Alright, so we have 1.0 kilograms is the same thing as saying 2.2 pounds. Alright, so if we use dimensional analysis to do this, we want to get pounds out of the denominator and keep kilograms in the top. And so what we do is we put our mass, or our weight in pounds. Let's say I weigh 220 pounds. In the top, that cancels our pounds out, and we're left with 1 times 220 divided by 2.2, which is 100 kilograms. Alright, so that is how we find the mass in kilograms. We just take our weight in pounds and put it up here. We take our mass there, we get our mass, and now we want to find out what our weight in newtons is. So that was A. B, we know that weight, W equals M times G, or force of gravity is our weight. And so we set our mass times our acceleration due to gravity. And so our mass is 100 kilograms times 9.8 meters per second squared. I have to pick out these numbers so they're easy to multiply, and we get 900, as I write the wrong number, 980 newtons for B. Number two, we have Gunter, and he's a weightlifter. He can lift a 230 kilogram barbell over the overhead on Earth. Acceleration due to gravity on the Sun is 274 meters per second squared. Would the barbells be heavier on the Sun or on the Earth? Well, A, of course, the weight would be heavier on the Sun. And B, how much in newtons would the barbells weigh on the Sun if it were possible to stand on the Sun without melting? Well, to find that, we say we have weight is equal to mass times gravity, and that would be equal to 230 kilograms times 274 meters per second squared. That is 4 sig figs and 3 sig figs, so our total is 3 sig figs. So we multiply 230 times 274, we end up getting 6.302 times 10 to the 4th newtons. 3 sig figs gives us 6.30. That was B. Number 3. In number 3, we have Sammy Sosa swinging at a 0.15 kilogram baseball and accelerating it at a rate of 3 times 10 to the 4th meters per second squared. How much force does Sammy Sosa exert on the ball? So we've got force. We want force is equal to mass times acceleration. And so we've got our mass of 0.15 kilograms. We've got acceleration of 3.0 times 10 to the 4th meters per second squared. And so we multiply those two together. So 0.15 times 3.0 times 10 to the 4th is equal to 4.5 times 10 to the 3rd newtons of force. So far, these have been pretty straightforward, just F equals MA or W equals MG. But we look at number 4, and we're looking for acceleration. We're looking for the acceleration of this table. And so Claudia stubs her toe with a force of 100 newtons. All right, so we've got force equals 100 newtons. We've got the acceleration. We want to find acceleration of Claudia's foot. So mass equals 1.80 kilograms. And so if we want to find acceleration, acceleration we know is equal to force divided by mass. And so we plug that in. So 100 newtons of force divided by 1.80 kilograms gives us an acceleration of 55.63 sig figs because we have 100 and 1.80. That is 5.6 meters per second squared. If we want to find the acceleration of the table, where mass is 20 kilograms, still 3 sig figs, so A is equal to F over M, which is 100 newtons of force divided by 20 kilograms, and that gives us 5. 3 sig figs gives us 5.00 meters per second squared. All right, so number 5, we've got chopping down the father's cherry tree. George discovered if he swung the axe at a speed of 25 meters per second, it would embed itself 2.3 centimeters into the tree before coming to a stop. If the axe head had a mass of 2.5 kilograms, how much force was the tree exerting on the axe head upon impact? All right, so we want to find force on the axe head upon impact. Well, we need to find the acceleration. That's how we find force. And so force is mass times acceleration. And we need acceleration. We've got mass, but we have v and we have x. And so we've got a v, and we can assume that that v initial, and then we have a v final is 0, because it says it comes to a stop. So we are looking at our formula here. We've got vi squared, vf squared equals vi squared plus 2a delta x. To find acceleration, we'll solve for acceleration. So we've got vf squared minus vi squared divided by 2 delta x equal to a. We know that vi squared is 25 squared, so 0 minus 25 squared divided by 2 times 2.3 centimeters. We need to change centimeters to meters, and so we've got what is that? Yeah. It's going to be 0 minus 625 meters per second, that's a squared, divided by 2 times 0.023 meters, and that gives us an acceleration of 586 meters per second squared. We want to make sure we've got the right number of sig figs. I've got a delta x of 2.3, so we need 2 sig figs. So this is going to round up to 1400. So A is equal to 14,000 meters per second squared, or 1.4 times 10 to the 4th meters per second squared. And that is our answer for our acceleration. Now, to find A, we want to know how much force was the tree exerting. So for A, force is equal to 2.5 kilograms times 1.4 times 10 to the 4th meter per second squared. And this is a deceleration, remember. This is a deceleration, and so we want to find this out, and so we end up with the force equal to negative, well, it doesn't really matter if it's negative or positive, it's still in a direction. So we've got 3.5 times 10 to the 4th newtons being exerted. All right, and then B, the force that the tree exerts back on the axe head is going to be equal and opposite. Okay. I have 5 minutes left, so we're going to look at number 6. Number 6, we've got a barbell. Vladimir Kurlovich from Belarus set the record as the world's strongest weightlifter. He did this by lifting and holding above his head a barbell whose mass was 253 kilograms. Kurlovich's mass at the time was roughly 133 kilograms. Draw a Freebody diagram showing the various forces in the problem. Calculate the normal force exerted on each of Kurlovich's feet during the time he was holding the barbell. So we've got a total mass of 253 plus 133, and so that means our total mass is going to be 386 kilograms. All right, and we're going to draw Kurlovich holding a barbell. You like my artwork, I'm sure. We've got 2 legs, and each of those legs has a normal force on it. So what is that normal force? Well, we've got a force of gravity pulling down, and that force of gravity is going to be divided into both feet. And so both feet have 1/2 the force of gravity. That force of gravity is being divided amongst those two. And so that means that we just flip these up and that becomes the normal force. So the normal force on each of those feet is going to be half of that. And so we say that force of gravity is equal to 386 kilograms times 9.8 meters per second squared, which gives us 3.78 3 sig figs times 10 to the 3rd newtons. And then we have, that's the sum of both of the left and the right foot normal. And so the normal force is going to be equal to half of that, which is 1.89 times 10 to the 3rd newtons. Question number 7. All right, we've got angles this time. So we've got the largest gorilla on Earth with a mass of 3.10 times 10 to the 2 kilograms, a 310 pound or 310 kilogram gorilla. Suppose a gorilla with this mass hangs from 2 vines, each of which makes an angle of 30 degrees to the vertical. So here is our gorilla. We have a force of gravity. We have 2 vines here, and the vertical, and this angle is 30 degrees. All right, so we've got a Freebody diagram. We have various forces. That means we have a force going up, a force going up. We have a force going to the left, and a force going to the right. I'm going to change colors and redo that. We got this force, we got this force. That means we also have this force, and we have this force, and this force, and we have this force. This is the force of tension. This is the force of tension. This is the force tension in the Y, or in the X direction. This is the force of tension in the Y direction, and this is the force of gravity. And so we can split that up a little bit. We have, let's see, we're going to find the force of gravity on the gorilla. So this is going to be force of gravity equal to 3.10 times 10 to the 2 kilograms times 9.8 meters per second squared. And that gives us the force of gravity is going to be 3,038 newtons. We've got 3 sig